All right. Day is July 6th. We're going to be talking about Advent of Code. I know I'm 7 months late, but better late than never, right? We're going to be learning, or we're going to be running this in Rust, see if we can figure out this problem. I've already taken a look at it. It looks like the main thing that we're going to have to worry about is serializing our input, honestly, is going to be the hardest issue. So let's see if we can't do that. Let's give it a go. Day 5 supply stacks. The expedition can depart as soon as the final supplies have been unloaded from the ships. Supplies are stored in stacks of marked crates, but because the needed supplies are buried under many other crates, the crates need to be rearranged. This ship has a giant cargo crane capable of moving crates between stacks. To ensure that none of the crates get crushed or fall over, the crane operator will rearrange them in a series of carefully planned steps. After the crates are rearranged, the desired crates will be at the top of each stack. The elves don't want to interrupt the crane operator during this delicate procedure, but they forgot to ask her which crane will end up where, and they want to be ready to unload them as soon as possible so they can embark. They do, however, have a drawing of the starting stacks of crates and the rearrangement procedure, your puzzle input. For example, in this example, there are 3 stacks of crates. Stack 1 contains 2 crates. Crate Z is in the bottom, and N is at the top. Stack 2 contains 3 crates. M, C, and D. Finally, stack 3 contains a single crate, P. Then the rearrangement procedure is given. In each step of the procedure, quantity of crates is moved from one stack to a different stack. In the first step of the above rearrangement procedure, 1 crate is moved from stack 2 to stack 1, resulting in the configuration where D should be on stack 1. That's right. In the second step, 3 crates are moved from stack 1 to stack 3. There. 1 at a time. Interesting. So the first crate to be moved, D, ends up below the second and third crates. Then both crates are moved from stack 2 to stack 1 again. Because crates are moved one at a time, crate C ends up below crate M. Finally, 1 crate is moved from stack 1 to stack 2. And the elves just need to know which crate will end up on the top of each stack. In this example, the top crates are C in stack 1, M in stack 2, and Z in stack 3. So you should combine these together and give the elves the message CMZ. After the rearrangement procedure completes, what crate ends up on top of each stack? All right, let's dive in. So I'm debating whether we serialize this generically or if we just throw it into our code. Might be an interesting challenge. I wonder. Well, let's do that. So when we do day 5, we're going to have 2 different operations. So one is going to be to serialize and deserialize our stacks of crates, and the other is going to be interpret the list of commands. And so let's make 2 modules. All right, so we have this. We have that. We have this. Let's just do a little bit of boilerplate. Obviously, we're going to need a main function. All right, it's catching up. We're going to need some unit tests. Mod test 5. And we're also going to need a function that can read each line of the input. So we're going to call this read to lines. It's going to take a path, which is going to be, let's say, path buff. We'll use that. And it's going to return a lines construct, standard IO lines, of a buff reader of a file. This is the idiomatic Rust way to do it. The buff reader kind of cuts down on duplicate memory usage, so it's a little bit faster, a little bit more memory efficient, and it's idiomatic. There's more details in Rust by example. This is where I pulled that. And to use the lines function, we're also going to need the buff read trait. Let's dive in. So we're going to let our file equal file open path, and we can just unwrap this. Normally we do better error handling, but this is just for us. So then we'll let lines, no, we'll just return, yeah, we'll do this. Let lines equal buff reader from, or new, I believe it's new, file dot lines, and that's lines buff reader file. We can just return that. There we go. And we'll return lines. Okay, so now we can read through lines, which is good. And let's see, we're going to have two modules. Mod rates. No, let's see. Mod oh man, we can't use cargo or crates. I mean, we can, but that's pretty funny because that's what we're using for our package manager. Containers. We'll just call it mod shipping. We'll say mod instructions. We'll probably rename those. It's kind of awkward. So under here, under bin, we can make a folder. We'll call it day 5. Day 5, say shipping.rs. And instructions.rs. And it should now be working. Let's just run a cargo check. Source bin instructions or source bin instructions. Interesting. Oh, interesting. Yeah. Okay. So what's going on is I have my binary file and I'm trying to create a module of the same name. Normally I'm used to working with like libs, library modules, where this sort of syntax would be just fine. Where this would be like a sub crate of this guy. But with binary files, it looks like that's not going to work. We're going to have to use, just going to have to rename this. So we'll call this day 5. Let's just do that. Use day 5. That's what's going on. So now we can use day 5 instructions. All right, it's freaking early, man. Use day 5 shipping. Okay, now we have these, so we can read stuff. And we can start building our modules. So the first thing I want to do is kind of model this. So I want to be able to model this thing as some Rust struct. I'm thinking we're going to have one structure, which is going to be our doc. And within the doc, we're going to have a vector of vectors of characters. And we have to figure out a way to serialize this input into that struct. And then for convenience sake, I think it might be an interesting challenge to define a print function or display function that will deserialize into this sort of format. So that's the only reason I have a separate module. Let's give it a go. We're going to start with shipping. Let's see if we can do that. Let's close that. Okay. So we'll say pub struct doc. And it's going to have pub struct port. It's going to have docs, which are, I mean, we could say docs are just a vec of docs, and then pub struct doc would just be crates vec of characters. Now this might be a little bit too much abstraction, so I'm actually going to get rid of that, and we'll just say vec of characters. Is that going to be too confusing? So then when we're accessing stuff, we access by port doc crate. And in reality, we're only ever going to be doing like stuff, actions like port / doc dot pop or push. So that's not going to be too bad. Okay, So now we have to define serialization, deserialization. Now, for a lot of this stuff, we could use SERDI, except SERDI is really complicated to implement, way more complicated than we need. Especially since this isn't like some standard JSON, so we can't utilize a SERDI JSON crate. So I'm going to be doing this by hand. Let's use super. Let's see. You know what? Let's actually drop our lines reader just into here. No external crate shipping. Oh, that's why. Grab all this. Shipping. So dumb. Pull this out. We want to put this here. Drop that in there. Let's just make that public. That's fine. So I've read to lines. Let's go to shipping. So use super. Let's be 2 lines. Does that work? That works. So we want to serialize. So we'll implement for port function that is deserialize. We're going to deserialize from lines of at a reference, a mutable reference, because we don't need ownership of it, of lines of buff reader of file. All right, and it's going to return self. So we'll let mute port equal port of docs. Let's see, docs is going to become up here. Pub use. Oh, here we go. Mod shipping, mod instructions, pub use. Oh, we don't have to worry about that. There we go. Come back over here. Day 5, we can undo those changes. Now that those modules, what's going on? Wow. That's a lot. File not found in scope. Okay. Okay, not gonna worry about that. Let's figure this out. One thing at a time. Get rid of this. Back over here. Mod, that looks fine. Shipping, not fine. Back, new. Let's just do that. Okay, so it will infer. Use super read to lines. Use. Need to import all that. All of this stuff. Almost. Well, we need buff reader. We have path buff. Need that either. Lines buff reader file. Read to lines. We haven't used it yet. Self. So we have our port. This is a new port. Newly initialized vector of characters. And we will return port. So now we have to do this. For line in lines. What's the best way to do this? What is the best way to do this? We can read through line by line, kind of storing it in a buffer. We have to know the width beforehand, I think. Or we can infer the width from the width, or the number of characters. Or we could just hard code it. Let's just hard code it for now, because this is junk. So this capacity here is going to be 9. spec with capacity 9. That tells us that we're going to have 9 docs. Has capacity 0 length, and that's just fine. We don't know strictly the capacity of the number of characters, so we'll just let Rust do its thing there. Now for line and lines. All right, so what we want to do maybe is, and I would love to go from the bottom to the top. I'd love to go bottom to top. Now, I'm sure there's something here in this buff reader package that would be very helpful. Actually, let me just take a look. Standard IO buff reader Rust. Buff reader adds buffering to any reader. It can be excessively inefficient to work directly with a read instance. For example, every call to read on TCP stream results in a system call. A buff reader performs large, infrequent reads on the underlying read and contains an in-memory buffer of the results. Buff reader can improve the speed of programs and make small and repeated read calls to the same file or network socket. It's not help in reading very large amounts at once, or reading just one or a few times. It also provides no advantage when reading from a source that's already in memory, like a vector. So we don't have to worry about that. And probably looks like it's not going to be helpful in our situation because we're only going to read 8 lines. Trait, standard IO read. So this is a trait. And I believe file implements that trait. Standard FS file trait implementations read. There it is. Why are there 2 reads? Oh, they're a bit different. Oh, very nice. And another reason this buff reader is nice is because it has that lines function. Sorry. An iterator over the lines of the buff read. Lines brings an iterator over the lines of this reader. Iterator I result string. String returned will not have a new line byte. And okay, yeah, so probably what we want to do is load each line into a stack, pushing it, which will reverse the order until we get to this line here. And we'll just hard code that in as well. And then we'll pop out each line, parse it, push onto this guy. All right. Are we going to have index issues? Yes. So let's not do with capacity. We'll just do this. Vec new 9. So now we haven't just allocated 9 docs worth of capacity. We've actually created 9 docs that are empty. So we're not going to get index issues when we start pushing stuff on. So we'll let temp ports equal a vector new of vec lines. I have to specify all this stuff. Oh man. Why is that being mapped? Don't have enough of these. Okay. Now for lining this, we're going to check if first char is a number. And if so, then we'll break. So if line, or let's do this, let line equal line dot unwrap. If line dot, this is a string, parse, not parse, split ASCII white space, returns an iterator dot next. So if we can split the line and the next character dot unwrap dot is alphanumeric. Oh man. We'll just check that. Break. Else temp ports dot push is mutable dot push line. Oh, very interesting. Yeah. Yeah, so we're reading through this. We're breaking this down into strings. So that was that issue. So we're going to break this down into strings. So we've turned our file into an iterator of lines, which gives us this nice utility function for line and lines. Returns a result of a string, so we're going to wrap it into the string. So then for each line, one line at a time, we're going to push it onto this vector. And it's going to get pushed into like backwards order. So this is actually going to be at the bottom, index 0, index 1, index 2, 3, 4, 5, 6, 7. And then we're going to start pushing them back onto this port vector here, this vector of vectors, splitting it into characters as we go. And then obviously the characters can get pushed onto their correct doc. Let's see if that works. Print line there with temp ports. We have to use debug mode. Print line temp ports. And let's just set up a quick unit test. Config test mod shipping tests. Create a new test. Use super. So use this function. Create a new test function. Deserialize. Test deserialize. We're not returning anything. So we will let lines equal lines from, or read to lines. Path is going to be path buff from input slash file.input.text. So this is just going to read our file. Drop that down. I'm going to let our lines equal that. Buff. Standard path buff. Yeah. So those are our lines. Let port equal port deserialize lines. Let's see that. At mute lines. And then, yeah. Let's put a little print line here too, just to see if we're breaking at the right spot. Breaking at line numeric. This is a macro. We will print line, which is just a string, so use debug mode. Let's give it a go. Cargo test shipping tests. Whoops. Cargo test shipping tests. Show output. Let's turn off the warnings. Allow unused. Okay. So breaking at line here, that worked. And then we have our vector. So the first line is going to be index 0, that guy, that guy, that guy, that guy. Yeah, and it goes through, and the last line starts with H, so we're good. That's working. So we've turned this into an inverted vector of strings. So now we can break that out. So we're going to create for string and temp ports. Let chars equals string dot chars. I believe that works. So now this is an iterator of the characters of a string slice. And then let's just map this to, what's the best way? Filter, maybe. Where the predicate is immutable, is a function that takes a mutable reference to self and returns true or false. So the predicate is if C does not equal, or maybe this, C dot is alphabetic. There we go. So now we're only getting the characters. That's nice. Oh. Now we have, break this up. Need that, we don't need that. Let's just see if this filter is working. So this should return, oh, and then dot collect. And we want to collect it into a vec of char. That's nice. So now we can print line chars, and we'll see if that's working. Need this print line. So what we should see is that same output from before, except only the letters, and each string is going to be its own vector, and each letter will be its own item and vector. Let's run that same test. Run inputs. Now that's weird. Nothing printed. A5 shipping test testy serialized. Oh man, I'm so dumb. I deleted the wrong thing. Let temp ports dot push line, right? Let's see. All right, so at index 0, we have vector stq lbmpt. That looks good. Oh, that does not look good. Okay, because we've lost all context about which doc it's actually in. So how do we do this? So what we want is everything wrapped by braces. We want their indices. Maybe we can just enumerate and map IC print line IC. Closure expected to take a single 2-tuple as an argument. Yes. All right, that is a lot closer. That's a lot better. Let's see if we let's also push this into temp ports. So now what I'm thinking we'll do is we'll grab the mapping of doc number to index number. And then we'll use that mapping somehow. Yeah, we'll create a quick, let's just create a quick let temp docs equal hash map. Hash map new. What we're going to do is this hash map is going to store a list of items, kind of like a Python dictionary, like a struct, but generic, of the key value pairs where the key is going to be the port number and the value is going to be the, no, we're going to flip this. This is going to be the character number, character index to port number. So as we load up as we load this up, we're going to be pushing on each one of these numbers here and recording what the character index is as well. So this is going to be 32. This is going to be 30. We'll just call this character. No, it's going to be 32. Let ports equal temp ports dot next dot into iter dot next dot unwrap. This gives us a string. Then we want to do chars instead of this we'll say for character and ports interior extractor character. Okay, if we'll say just C, if C dot is alphanumeric, oh, we got enumerate dot enumerate. All right, so if C dot is digit, C dot is a base 10, then temp docs dot would be push insert character index I, while the port number is going to be C dot parse U32. How do you do that? Parse character into int rest. Two digit radix base 10. Oh, unwrap. We'll do use size then. All right, so what's going on is we pull out that first line of our, so we grab all of this and kind of invert it. So this is index 0. And we grab that line. In fact, we should probably just, we don't need a for loop in here. So we don't need that. This is a result string error. Temp ports is a vector string. Okay, so we'll do temp ports dot characters for C in temp ports dot characters. Temp ports 0 dot character. Okay. Okay, so now we just grab the first line of this, which is going to be this guy, turn it into characters, and enumerate them. And so then we'll push, if this is a number, we'll push the number and its index into this hash map. To see if this is working, let's run a test. Oh my goodness. What's going on? Here we go. So then we'll print this. So the purpose of that is so that we can, as we're parsing the rest of it, we can just pull out, for each line, we'll pull out the index of the character and the character itself, and we'll push the character. We'll map that against this hash map. We'll match it. Figure out which doc character has to go to. We'll print this line. Turn this into, so we're gonna have to do that. Print the hash map temp docs and run this test. Did not compile. All right, that's a dumb. It's just dumb. Empty. Empty. Print line C. What's going on? Oh. Oh. Okay, that's why. Dot last. Dot unwrap. Okay. I was pulling out the first one. The first one has no numbers. This condition was never being met. The hash map was staying empty. Let's try this again. Oh, we don't need this. 25715152. Okay, so this is saying is port characters corresponding to port 1 are in the character index 1, which makes sense. That's 0, 1. 2 is going to be, port 2 is going to be character 5, so 3, 0, 1, 2, 3, 4, 5. 6, 7, 8, 9 is 3. That's good. That's good. That's looking good. Now I can do this guy. All right, so for string in temp ports, let characters will string dot enumerate, string dot characters, dot enumerate, Need to do any maps right now. We'll just use a regular for loop. Oh, I love them. For I see. All right, I have this nested for loop. Let's just temp ports dot pop print line temp ports. Okay, so I'm just going to pop off the last line, which should leave us with just the characters, and then we can go back and do our thing. Oh, okay. Let's test this. That's all there. We're not missing anything. Okay. So if I in using Python syntax temp docs dot contains key character index I, then we want to push C onto the doc number that corresponds to oh shoot, I think this is going to be upside down. Well, whatever, we'll figure this out. Then we'll do this. Port dot docs I dot push C print line debug port. I'm gonna have to derive debug. Okay. Yeah. See what happens. Index out of. Oh yes, I minus one. By 1 error. Length of 9, but the index is 12. Oh. Temp docs dot entry E is going to be. No, we don't want that. How to access values. Map. How to access values in hash map Rust. Get. Okay. Get. Unwrap. What's going on? Slice indices are type usize or ranges usize. At I is U32. U32. Why is that U32? This should be usize. Oh. character index, U size, port number. Let's just do U size. Don't worry about all. So into. Okay, this is confusing. Okay, the type cannot be indexed by U32. Crate. So what's happening is we're trying to get an index of docs, but to get an index we need a U size, and we have a U32. Can it be indexed by U32? Implemented for U size. Let's see if there's a fix for that. Let port number equal U size. Docs. At U32. That's U32. Dot into U size. Port number. Doesn't work. We can do try into. Okay. All right, so we got to convert this U32 here into a U size so that it can be the index of the vector of vectors, which represents a doc. So this is actually doc number. Okay. Let's give it a go. So, oh yeah, so once we get that number, then if it contains, so for each character in lines, the program asks, is that character's index mapped in this hash map? And if it's indexed, then we will push that character onto the indexed port number, which this is doc, onto the indexed doc number. Yeah, that's it. All right. Let's see. Failed. Failed. Option unwrap on a value. Okay. So let doc number equal this. If let some doc number, if let some number, call it n equals doc number, then do this. Bunch of nests. Maybe it's too nested. N dot try into let n size equal n dot try into dot unwrap. Try using a fully qualified path to specify the type. Okay. So we're going to dereference this so we get the U32. We're going to try to turn it into a U size, then we use that. Okay. Let's give it a go. Oh man. Failed. Index out of bound. Oh my goodness. -1. And minus equals 1. Okay, we're back. Docs. So doc 0 is SLF ZDERH. Yeah, okay, so that's there. And it's empty. It's just empty. If this contains that key and C dot is alphabetic. All right, that should clean it up a bit. You'll notice we have a bunch of white space in these docs here. Let's get rid of a couple of these print line statements. Okay, the final issue we have before we're fully serialized, deserialized, serialized, I think. The last thing we have is these are backwards. Reverse. Can we just reverse a vector? Reverse a list. Oh, we've reversed it twice. This for sure is not very efficient. Luckily, it's like, 100 characters. For doc import docs. Doc reverse. What an interesting issue. So this is we're gonna have borrow checker issues here. Borrow of partially moved value port. Partial move occurs because port.docs has type vector of characters, which does not implement the copy trait. All right. So we got to do this right. Can't copy a vector of vectors. Can we just do this? We'll probably have an issue. Let. Let's try it this way. All right, so port.docs, clone it, turn it into an iterator. We map it. Turn D again. Select port. Man, freaking tired. So we're going to change our port.docs by cloning it, turning it into an iterator, reversing all the items, and turning it back into a vector, and then reassign that to port.docs. And test it. I believe it should be correct. So 0, 1, 2, yeah, okay, okay. Wow. report. Let's get out of here. Well, yeah, let's get out of here. So let's see. Use day 5. Public. Read everything. Read to lines path buff from inputs slash 5.input.text. We'll let lines. Oh, yeah, we don't need it. We don't need it. Okay. Okay. So we know this works. So that we need use shipping port. Private function. Okay, we have our port. Okay. Okay. I have had some sleep. It's the next day, July 7th, about the same time. So I've been thinking about this solution, and I think this instructions crate or module will be a little bit more than necessary. We'll just write it all in line over here. Let's dive in. So we have so far read file input to port struct. That's done. Next, we need to parse instructions. And then we need to run the program, I guess. All right. So the way the instructions are set up is move 6 from 1 to 7. So instructions move X from Y to Z, where X is number of crates, Y is origin doc, and Z is destination doc. So to pull this apart, we'll create this function, public function, line to instruction, parse instruction, and it's going to take a reference to a string and return X number of crates, so U32, Y origin doc, which I believe is a use size, because that's just an index. Use size, Z use size. Let's move this over a little bit. And we don't need variable names in there. So man, syntax is confusing. Let num crates equal U32 equal we just initialize a new one? We'll just say 0. Let origin uSize equals 0. Let, oh, these are mutable. Mute destination uSize equals 0. And we'll return num creates origin destination. Cool. So let's figure out how to do this. First let's split this line by white space. We get these tokens. So let tokens equal line dot split ASCII white space. This is going to return split ASCII white space. Iterator. And we don't want an iterator. So let's collect it. Should we take ownership of this line? There's no reason not to. Make this a little bit easier. Let's see. Dot collect, and we'll say vec of string. That is unfortunate. Vec, can we do this? It'd be much easier if it was owned. Ah, crap. Dot map string to owned. So we just turn it back into an owned string because I don't want to deal with lifetimes. Those things suck. All right. All right. So we have a vector of strings. Okay. Num crates equals tokens 0, 1 dot parse u32 dot unwrap. We'll call this expect issue parsing crates. So this will take the second token, which is this digit here, and parse that as an integer. There we go. This will do the same thing. 0, 1, 2, 3. Call this origin. And call this uSize. And we'll do the same thing for destination. 3, 4, 5. 0, 1, 2, 3, 4, 5. Issue parsing origin. Issue parsing destination. All right. All right. That looks good. And this is very easy to test. This is what unit tests were made for. Mod day 5 tests. Create a new test, and we'll call it function test parse instructions. And let num rates, well, we'll just say x, y, z equal parse instructions on, let's clean this up, on line. And we'll let line equal this guy, .to owned, so it becomes a string rather than a string slice. And now we can assert equals x 6, y 1, z 7, and we can run cargo test day 5 tests. We can allow unused while we're doing this. Value assigned to destination. Cool. Yeah, this isn't great. I should just initialize it when we initialize it, but not a huge deal. He's just there. No, that worked. So we're parsing this correctly. So we have a functional parser. And so we're going to go back to our main function and throw that in there right here. For line in lines, let x was number of crates, origin, destination, equal parse instruction line. So now we have this. All right. Let's move on. So we pull out what instructions are required, but how do we operate on instructions? That is going to be here. So we'll create a new function, operate. I mean, I suppose we could put this in the impl block. Actually, that might be a little bit better down here. So we're going to create a new function under implementation and report. It's going to be a method that takes in these 3 parameters, number of crates, origin, destination, and performs the push pop however many times as appropriate. So we should call this pub function push pop. We have number of crates, u32, origin, u size, destination, u size, and we don't need to turn anything. So, but we are modifying at mute self. All right. Okay. So the way we're going to do this kind of pseudocode is for I in num crates, destination dot push origin dot pop, because pop will pull from the top and push will push it to the top. And actually that it is just going to be as easy as that. So for I in 0 number of crates, self dot docs vector of vectors, self dot docs index origin dot push. Why is it yelling already? Oh, self.docs.push value, and the value we're pushing is self.docs origin, no, destination dot pop. And pop turns an option, so we're going to unwrap that option. Push just works, doesn't return anything. We're going to push onto the destination the top element of the origin. All right, let's test this. Function test push pop. Let port equal, let's just initialize a port here. In fact, we don't even need it. We'll just do this. Init port. Port. So let port equal port. Can we get default? Default? Oh, but we don't want default. What am I doing? That would be easy. That'd be too easy. So we want docs vector A B C. We'll have three of these: A B C, E F G H I G. We'll just return that. All right. So now we can run our test. Test function test push pop. So we'll let our port equal init port. And on this port operation, we want to run this push pop function. So we'll make this mutable. Port.push pop, number of crates. Let's test pushing all three from 0, from this one to the last one. And assert that port.docs 012, oops, equals vector of GHI CBA. And okay, yeah, so one at a time, we're popping off the last one, pushing it onto the top of the first one, and we can run this test, cargo test, shipping tests. What's going on here? In our main binary, that's done. All right, here, find.unwrap. Try it again. Oh, this is interesting. We can't do two mutable borrows at the same time, which is fine. We can just do one mutable borrow at a time. Let crate, not crate, let container, the shipping container, and we'll push that container. That should work. Failed. Beautiful. Option unwrap. None value. At 54. 54. Oh, I think I'm counting too high. I think that's an off by 1 error. Actually, can we just do this? Yeah. Okay, yeah, that was it. It was just an off by 1 error. So now we have this public method where we can just feed in this stuff. I think we have everything set up. Let's just go ahead and let's just try to solve the puzzle. And if it doesn't work, we'll figure it out. So let port. So we initialize our lines. Oh. At mute lines. That deserializes. I believe the next line is going to be white space. Because this function here, this deserialize function, is going to read everything 0, 1, 2, 3, 4, 5, 6, 7, 8. Then we call next line, it's just a blank line. Print line. So let's just get rid of that next line and then let our function take care of the rest. Print line. Where the next line we want to read is lines.next. What's going on? Option result string. Yeah, let's just unwrap that. Result string. Let's not even unwrap that. Print line, dropping line. Let's just run the test. Cargo, run this, just to see what's getting dropped. Binary, day 5. So I'm okay, good. Yeah, so this is dropping our empty line, and the rest of the lines are just going to be instructions. So for each line, we pull out the instructions, and then we run port.pushPop, number of crates, origin, destination. This has to be mutable. And let's print line port and see what pops up. Option unwrap on a none value. At that same. Let's do some better error handling. Where is that dropping? Line 50 something? 54? This guy. So we'll let container result equal this. If let sum C equal container result, then we can do this. Else print line. That's just going to give us a none, isn't it? Print line, well, we'll just do this. Failed. Push. Pop failed at X, Y, Z, X, Y, Z, X. Crates. Y is origin. Z is destination. Let's see what happens when we run this again. Push pop failed here. Index out of bounds, the length is 9, but the index is 9. Oh, that's its own issue. Length is 9, but index is 9. I think we're doing... Oh. Okay, -1. Origin -1. Destination -1. That's an off by 1. That might fix the issue. Oh, I'm just being dumb. Oh, that worked. Okay, yeah, that's great. For so now I just got to figure out what the top character is in each of these docs. We'll say for doc import dot docs dot enumerate. And we'll say for doc number and doc. We just have to say into iter. Print line. Top doc. Top character in doc is doc number is doc dot pop dot unwrap. Why is this freaking out? Okay, let's see. So the top character in doc 0 is R. Oh, and the doc numbers, man, off by 1. I plus 1. All right. So top character in 1 is R, N, Z, L, F, Z, S, J, H. 2 Z's. Is that right? There's a lot of Z's. Let's see if that even makes sense. If we go to our input, hopefully we see a lot of Z's. Z, Z, Z. Okay, yeah. That's good. Let's put this into our answer. And see if we got it right. And if we did, then we can move on. Answer is we will just print this. Copy that in. That's it. We did it. That's right. All right, let's go to part 2. As you watch the crane operator expertly rearrange the crates, you notice the process isn't following your prediction. Some mud was covering the writing on the side of the crane. When you quickly wipe it away, the crane isn't a crate mover 9000, it's a crate mover 9001. Crate mover 9001 is notable for many new and exciting features: air conditioning, leather seats, an extra cup holder, and the ability to pick up and move multiple crates at once. Again, considering the example above, the crates begin in the same configuration. Moving a single crate from stack 2 to stack 1 behaves the same as before. However, the actions of moving 3 crates from stack 1 to stack 3 means that those 3 crates moved stay in the same order. Next, as both crates are moved from stack 2 to stack 1, they retain their order as well. That makes sense. Okay. Before the rearrangement process finishes, update your simulation so that the elves know where they should stand. Be ready to unload the final supplies. After the rearrangement procedure completes, what crates end up on the top of each stack? So, core functionality that changed is in shipping this push pop function. Rather than just being a simple push pop, it's more of a push pop from start, which should be trivial to pop from start. And instead of this pop here, this push, pop, pop, let's see, let's do this. There's got to be some way that's like idiomatic. Something like slices. Can we push and pop slices in Rust? Pop vector slice Rust. Under vector shortens the vector, keeping the first length elements and dropping the rest. Oh, the drain method can emulate truncate, but causes the excess elements to be returned instead of dropped. Removes a specified range from the vector in bulk, returning all removed elements as an iterator. If the iterator is dropped before being fully consumed, it drops the remaining removed elements. The returned iterator keeps a mutable borrow on the vector to optimize its implementation. Rain. So let mute vec equal 1, 2, 3. And this will drain from index 1 forward. Will drain 2 and 3. All right, that is perfect. That's exactly what we're looking for. So let stack crates equal self.docs origin -1 dot drain, and we need a range, which is going to be origin, no, number of crates forward. Huh. Oh, that's frustrating. Number of crates. Doesn't like that number of crates is U32. We can say let num crates equal num crates dot try into and we want to turn it into a U size. It's going to throw an error, so we can just unwrap it. That works. So we pop the last stack and then self.docs destination -1. We want to push, but we're not going to push, we're going to append. And the thing that we're going to append is this rain, which we're going to collect into vector of characters, and we can append that stack there. It's going to yell because it wants a reference to it. At mute. At mute. All right, this might work. So instead of popping off one at a time, we're going to use this drain function, which pulls off a range from the end. Select that into a vector and append it to the end of the destination doc. And we are using all of our things, all of our variables. Let's write a new test. Function test push pop. What do we call it? From start. Let mute port equal init port dot push pop from start. The same thing. And we're going to expect a very similar output, except that these last 3 letters, this isn't going to be flipped. This is going to be A, B, C. And assert equals port.docs 0, the origin, because we've drained this whole thing. So is there a length? Yeah, is 0. So that length should be 0. Let's give it a go. Failed. That's it. Because we fixed that thing. So I'm using the wrong index again. It's another off by 1 error. Can have them all day. All right. This is better. We're back to here. Assertion failed left equals right. The left is GHI. Where the right is GHIABC. Uh-huh. Let's figure out what's going on. So for whatever reason, it wasn't popping anything. I wonder, did it drain it correctly? No, it didn't drain either. Port.pushpop from start. Port.pushpop from start. Let mute stack equals self.docs origin dot drain. Print line. Just throw in a couple print lines here. Stack. See what that says. See what that says. Oh. Show output. Nothing. That's nothing. Why is that nothing? Oh. We want the length of this to be the number of crates, but it's actually going to be let length equal self dot docs origin -1 dot length. And this here is going to be length minus num crates. Okay, so this is going to pop off starting at the index number of crates back. So yeah, the issue is we were starting at index 3 on a 3 length doc when we want to start at index 0, which is 3 minus 3. All right. Let's give it a go. Fast. Nice. Push pop from start. So let's go back and just solve this. Push pop from start and give it a go. So all I did was change this function call here, push pop to push pop from start. Everything else is the same. Let's just print line starting part 2. We don't need this guy. We do want this. And we might as well put it there. And run it again. Copy and paste our answer into here, submit it. It should be good. That's it. We got it. So let's just review what kind of things we implemented. All right, so in our crate, we solved a couple issues. The biggest issue was parsing an input and turning it into a structure. So to do that, we defined this struct port. And now we could have called it port is a vector of docs and the doc is a vector of characters, but we decided to skip the abstraction and just call the port a vector of characters. We implemented this deserialize function, which split the line by character, kept track of the character space, the character index, and character SSI doc value in this hash map. And then we could call upon that doc number and character index to properly insert each character into the correct doc. Yeah, so that was fun. We also implemented a couple of functions for pushing and popping values off the top of each doc, which is a stack of characters, either one at a time or in bulk, using this nice drain function. Did a couple of tests. We also produced this function here, read to lines, which uses idiomatically will turn a file into a buff reader split into lines, so an iterator over the lines of the file, which is very handy. We also created this parse instructions value function, which will split a string by white space and collect it into this vector of strings, and then turn each string in the vector to token, or to an integer rather than a string. And we use that to feed into the push pop functions. We got our answers.